Good morning to all. Welcome to ImageGrafix Wednesday webinar. And today topic is FE analysis tool for the PVElite users. And my name is Pandian. I'm a technical manager in ImageGrafix. So I'm just taking you through this next 30 minutes to discuss on the FE analysis tools available for PVElite users, of course. Okay, if you see the agenda today, so we need to just trying to understand that where to use the FE analysis in PVElite, in which area, the why we need to use the FEA analysis requirements on the PVElite point of view. See, then how to use this FE analysis in PVElite. Okay, we will try to understand why it's required. Then how to use it, of course, that's the second point which we will be discussing it, and what is the benefit out of using the same. So this is what the point which we are trying to discuss today on this webinar. Okay, so let's start with that first point, that where to use the FE analysis in PVElite. Typically, the PVElites follows the beam theory, which is going to be mostly, sufficient enough to address the ASME code requirements for you. However, in some of the areas, where you will be in a position to need of doing a FE analysis requirements to fulfill the code details, of course. Okay, so one of the point here is obviously the TEMA 9th editions implemented the FEA calculations for the thick expansion joints. Okay, so if you want to perform the thick expansion joints calculations when you are doing the heat exchange analysis, fixed heat exchange analysis, then obviously as per the 9th editions, there is a need for the FEA calculations, and that is the place, you can see that there is a need for FEA. So that's the first point. Then another one is which is quite used for long time. That's on the WRC 107297. So typically we do the local stress analysis for the nozzles by means of WRC 107 or 297s according to the requirements what is with it. However, these WRC code are considered weak in some following areas which is listed out in this place. So wherever there is a WRC 107 and 297 as considered weak, you need to go for a supporting calculations requirements. Even sometimes the customers also ask us, this place the ASME inspector are not accepting the WRC calculations and they're asking the supporting FEA calculations. So in that place, obviously, where you need to go for a FE analysis to fulfill your ASME inspector requirement, of course. Which are the points considered weak in WRC 107-297 is listed out here in this place for you. Typically, the D by D ratio, the 0.5, the D is the diameter of the nozzle with respect to the diameter of the vessel. If this ratios goes below 0.5, then obviously you may in a position to go for a FE analysis. As we all know that WRC is a chart-based standard, so they will be having various charts, and you need to take the values from this chart, and you will be fulfilling the details with respect to the same. The WRC 107 has the chart values till 0.8, and then WRC 297 has the chart value till 0.5. So anything goes below 0.5, then obviously you may in a position to go for the FE analysis to fulfill the need. Probably the below 0.5 also currently you might be using PVElite and you will be doing the analysis, but that may not be the right method or the procedures to do the same. Even though you are getting the output, but the output may not be the right one, because typically what will happen in WRC, the values goes, even though the values goes below 0.5, since the WRC chart does not have a values for below 0.5, then it will use the last curve available data, which is if you are using WRC 107, then the last curve available data is the D by D ratio is 0.8. So even though your current ratio is below 0.5, but still WRC use a 0.8 curve value data, and it provide the results with respect to the same, which is not the correct, which is not the accurate values, of course, but obviously it is going to be on the slightly on the conservative side, so probably your system may get fail actually. So that's what the point which we are trying to highlight in this place. Apart from this, if you see there are few things which is pretty straightforward, like the pad reinforced nozzles. So if you have a reinforced pad nozzles used in your system, then obviously the WRC is not going to address the same. So you need to go for a FE analysis. Similarly, the hillside nozzle, lateral nozzles, then obviously the straightforward requirement is FE analysis, because WRC address only the radial nozzles. So whenever there is a radial nozzles, then WRC has been fine. Even for the radial nozzle, there are the few more limitation, like this D by D ratio, temperatures on the creep rim, and then the fatigue, cyclic load, the fatigue cycles, if it goes more than 5,000 cycles. So these are the criterias where obviously you may need to go for the FEA analysis, and WRC 107, 297's results are considered weak in these particular areas, of course. All right, so this gives the idea to us now where exactly to be used the FE analysis for the PVElite users. For the nozzle analysis, directly you're trying to use it. And second thing is on the for the heat exchanger side, the TMA 9th editions, the thick expansion joint calculations, implementations also, you may need to use it, of course. Okay. Now let's see how to use this in PVElite. All right. PVElite 2015 allows you to perform the FE analysis on the thick expansion joints. This is a new features they introduced in 2015. PVElite 2015 released in this year, January 2015, and you will be having your options right now. If you go to the expansion joint area, you can option to find now there is additional options called FEA in this place. Earlier, we will be having options of only this TMA and then the Cops and Sawyer. These are the two books which they are using it earlier. But now the new option, you can see this FEA which has been introduced additionally into the same. So now you can option to select this FEA and it'll ask you few more informations to perform the FEA related analysis. So once you provide the information, then the software, when you go to the output as usual way, you can option to see the additional results would have been come with respect to the FEA analysis for you. Okay. And when you choose this FE options from this PVElite expansion joint menu, then it may not know question to work directly. For that, you may need to have a add-on software called Nozzle Pro. Okay, so Nozzle Pro is a third-party products which has an interface with PVElite. So once this Nozzle Pro is installed in your PC, then when you select this option called FEA, then in background it initiate the Nozzle Pro software and it's perform the analysis. Then you will get the results in PVElite output itself. Just to run the analysis on the background, obviously you may need to install this Nozzle Pro software in your PC. Okay, so typically if you see that you're not trying to do the analysis in separate software, you're working in the PVElite environment, but but in background it uses Nozzle Pro software for you to perform this FE analysis. Okay, so now if you are a user of PVElite 2015 with a Nozzle Pro software, which means you can now position to fulfill the TEMA 9th edition FEA calculations for the thick expansion below joints, which is something is not possible till PVElite 2014. So that's a new features which has been added with the interfacing with Nozzle Pro software. Okay, so let me go to the next one. This is the way you are trying to addressing the thick expansion joint, and I'll be showing you the same in the software too how to do it. Let me just finish off the next point, that is a WRC. So how to do the F analysis and PVElite, which is for the WRC side. WRC side, the link has been the interface has been available by means of CodeCalc. So if you go to the CodeCalc, in the CodeCalc already WRC 107 analysis is available for you. Similar way, if you just click on that analysis options, apart from WRC, you might be finding one more option called FEA. So you can select the FEA options and you can perform the FEA analysis for the nozzles in CodeCalc, of course. And again, the same thing, in order to run that FEA inside the CodeCalc, you may need to have the Nozzle Pro software installed on your PC. Once the Nozzle Pro software installed in your PC, then you can select the FEA options. You can push the button called analysis. Then software will perform the analysis. It will just in the background it initiate the Nozzle Pro. It perform the analysis and it gives the results within the CodeCalc environmental for you again. So again, we are trying to do the same thing, typically the way it has been done in the PVElite for the teamer, same thing which we are trying to do for the WRC 107 in CodeCalc, of course, for you. So this is the way you can perform the analysis for the FEA for nozzles inside CodeCalc environmental for you. Okay, and I'll be showing a small sample on WRC analysis too for you. Okay. So we are talking on this particular part, the Nozzle Pro, and what is the significant and what exactly this product going to help us on the same. So first thing is, let's try to understand the developer of this Nozzle Pro. Pauline Research Group (PRG). It's a Houston-based research company. Is a developer of this software called Nozzle Pro. Okay, and this software has been available in the market for nearly 20 plus years now. Of course, the Tony Pauline, uh, who is the original author of Caesar 2. Tony Pauline is the one who wrote the Caesar 2 in 1985, 1984, 1985. He was employee of CodeCalc at that time, and then first release of Caesar has been wrote by him, of course. Then about in 1988 or 89, he just come out of the CodeCalc and started his own venture. So that is a Pauline Research Group, and he started doing the research, and he started making the software which is FEA based instead of the beam theory what Caesar and PVElite works, of course. Okay. What is the significance of PRG? If you see, PRG is a very well-known research group in Houston in US, and most of the times the code wants to do any changes in their system. For example, ASME wants to do some improvement on the code. They will go to PRG and they will use their research lab to do the testing and with respect to the results which they will implement into their code. Similarly, the team also does the same. If you see that examples on this way, that in 2007 we would have seen the major changes on the nozzle reinforcement calculations in the ASME Section 8 Division 2 2007 edition, and this has been recommended or the research has been done in Pauline Research Group. And what are the test results which has been comes out of their lab, which has been get implemented into the ASME code, of course, for you. The same way, ASME awarded one more projects called SDLLC. That's mainly for to find out or improve the I and K factor value. It's typically the stress intensification factor and then flexibility. Now further next to that is a sustained stress index. So these calculations, methodologies, procedures based on the FEA method, ASME awarded projects and PRG does the research on the same, and they just given back their feedback and opinion to ASMEs to implement into their code, of course. The same way we are talking about the 9th editions of the TEMA, where it has gone for the FEA based method for their thick expansion joint, and this research also has been done by Pauline Research Group, and they have only recommended to TEMA, and based on that recommendation only TEMA has done the changes in their 9th edition, of course. So if you see, they are a pretty strong background research companies, and they are being used by all the codes even for their improvement, of course. So the same company, what are the research results just given to this course and has been put it into the products, and that products is available here as a Nozzle Pro for us. So because of their expertise and available in this area for more than 20 plus years, Intergraph is trying to use their expertise and to provide the FE analysis solutions to our PVElite user. So that's the reason wherever there is a need for the FEA, what Intergraph does, they have a tie-up with Pauline Research Group, and they are providing these Nozzle Pro products for this PVElite users with a very tight integrations to us, of course. So by means of this, for us, our advantage is basically to right now to make use of the well-known research products to our FEA need and do the analysis. Because I know that wherever there is a requirement pops up on the FEA side, uh, sometimes I could see that people will just go for the general purpose FE analysis tool available in the market, and they are trying to replicate the requirement model in the general purpose FEA tools. Then they are performing the analysis with respect to the same to get the required result. However, when you are trying to use the general purpose FEA analysis tool, that is not going to compare your results with the ASME or TEMA requirements and to go giving the report to you. Here, the advantage is this person does the research mainly focused to the PVP industries. There is a pressure vessel and then piping industry. So wherever the pressure vessels or piping is available, so that is a place, the pollen research groups research is going on mainly for you. So that is the reason this FE analysis which you are performing is it's going to compare with the appropriate code requirement, and it's going to give the results to you. So the Nozzle Pro performed the analysis as per the ASME 68 Division 2, Appendix 4 and 5, which is addressed uh, mostly for the FEA requirements, and that is where it's been implemented into these products. So you will get the allowable loads with respect to the same, and it's compared with respect to that and give the results whether it's pass or fail to you. Okay, so that's a key advantage. And Nozzle Pro, on the PVElite point of view, even though I talked about mainly on the thick expansion joint and the nozzles, apart from that, the Nozzle Pro has a facility to perform the FE analysis for the saddles. That is probably you can consider as a replacement of the zig analysis. Then it has the vessel attachments. So in order to support the pipe, if you are taking a the vessel attached from the structural which you are taking from the vessels. So if you want to perform the FE analysis for that also, you can position to use Nozzle Pro on this. Apart from this, for the fitness for services APA 579 analysis, PVElite does the general metal loss, local metal loss and pitting, and if you want to perform the crack like flaws, then obviously Nozzle Pro is a product is going to helpful for you, because the crack like flaws need the FEA method to perform the analysis as per the ASME as per the APA 579, and this has been implemented with Nozzle Pro. So when you are doing a re-rating of the existing vessel, obviously PVElite is going to helpful for you to perform the general metal loss, local metal loss and pitting, and then obviously for the crack like flaws you can push and use Nozzle Pro, which makes your complete analysis suit requirement according to the vessel kind of the flaw what you will be having it for you. So that is what the usage on this, and these are the geometries which I talked about, right? One is you can see there is a nozzle, saddles, and then the vessel attachments. So all these things which you can position to perform by using Nozzle Pro for you. Okay. All right, let us go to the PVElite software. So first I'll show you on the how we can position use it on the TEMA and the thick expansion joint side. Then obviously I'll show you the WRC2, of course. Here is a sample, the example model available in the product. I'll be just showing you this. So we have a heat exchanger. It's a fixed heat exchanger. So we are doing the ASME UHX. ASME UHX again using the TEMA for the expansion joints calculation. So I'll be just going to the expansion joint in this place right now. So in this place, if you see the expansion joint area, so here is the options for you right now. The thick expansion joint calculation method, we have TEMA, Copson Sawyer and FEA. So these are the three methods available. Till PVElite 2014, it's only two, TEMA and Copson Sawyer. In PVElite 2015, they added this FEA additionally to you. Okay, so first what I'll be trying to do is I'm just performing the analysis with the TEMA, typically what we normally used to do. Let's review the report with respect to that. I'm just pushing this double run man button to just get the output of the thick expansion joint calculation as per the TEMA, and I'm just going and clicking on the report. And you can opportunity to see here now. This is what the results which is been showing right now here. So this is displays the summary of the expansion joint results as per the TEMA ASME Appendix 5. Okay. So you can opportunity to see this is the results what you have got it right now, right? So now the similar analysis, if you want to perform as per the 9th edition FEA point of view, then you can just go back and change to the FEA method. Okay. So this is typical results what you will be getting it, which is already known to you. I'm just going back now to the input screen. I'm changing the options to the FEA. So once you change these options to FEA, you may probably need to provide two more data. One is the elastic modulus, that is optional. When you put 0, then the software is automatically going to calculate this value, based on the information available. And second thing is the Poisson ratio, of course. So the Poisson ratios which we need to provide. And here is the FEA runtime options. When you, what is your purpose of doing this FEA analysis? To find out what, there is the options to calculate the stiffness only, or the shell side pressure, or the thermal displacement, or tube side pressure. So we are trying to find out the displacement due to the shell side pressure, or the tube side pressure, or the thermal displacement for both, or finally the UHX combinations. When you put this UHX combinations, then it is going to select all the UHX combinations available. For example, I can just list out what are the options available to perform this UHX side. You could see this is what then. So the ASM and TEMA tube sheets models use TEMA 937 standard for the thick expansion joint calculations. So this is what we are trying to use it, of course. Okay. All right. So let's after changing this now let's perform the analysis back with the FEA now. So I'm just going back to the results now. The same ASME, tube sheet calculations output only we are here now, but I'm just you could see now the information has been got changed now. The expansion joint stress summary PRG Pauling research group. So now it has used Nozzle Pro. I have installed Nozzle Pro in my PC, so it is used that one. The stresses was calculated using TMOS 9th edition. So the load cases, since we have inform all the combination, it has automatically built all the 7 typical load cases, and it has performed analysis for all the 7 load cases. That is the displacement due to the tube side pressure, cell side pressure plus cell side displacement, cell side pressure plus cell side displacement plus tube side displacement, both pressures of course, thermal displacement only, displacement due to the tube side pressure plus thermal displacement. So these are the 7 combinations of the load. It performed the analysis and it has given the detailed results with respect to the same for you. Okay. So if you have the Nozzle Pro installed in your PC along with PVElite 2015, you can now push to perform the thick expansion joint calculation as per the TEMA 9th edition now within PVElite. So if you see that, you would have not seen anywhere that I am using Nozzle Pro, of course, right? Which has been which is installed in this PC, but software just take that exe file, run it on the background, and give the results on top of this place. All right, so this is the way you can push into do the analysis for the teamer. And then next thing I'm just moving on right now is a WRC. So you see, this is the place, your CodeCalc window. This is a new improved CodeCalc window. People who are using CodeCalc for last 2-3 years, I believe. I think 2013 they changed this format, and it just have a quite improved lot of facilities now, of course. So now in this place, if you see that here we have option to select the WRC 107. Once you select this WRC 107, then obviously you can just come here for the analysis type. In this analysis type, you have the two options. One is the WRC 107, another is FEA. So this FEA is nothing but Nozzle Pro. So first, let's try to perform this analysis by using WRC 107. So typically, if you see, this is a nozzle which has a reinforcement pad, of course. So if the nozzle with the reinforcement pad, then WRC 107 is not the right method to perform the analysis, because WRC has the limitations which is not going to perform with respect to the reinforcement pad. However, when you are trying to do this, so you will be getting the bit conservative results. So I just performed the analysis, and you can push to see the summary results. The system is failing right now. In the PM, on the sustained condition, PM plus PL is about 206 and then 264, which is probably coming how much? Let's say 264.33 divided by 206 point 85, which is approximately, it's about 27 percentages on the higher side. And the next one is PM plus PL plus Q. So that's for your thermal side, and that is also about 430 from 400. 413.13 is allowable, but actually it's 430. That's also on the higher side. It's almost failing in all the conditions for you. But now what I'm trying to do is I'm just going back to the analysis type. I'm changing this to the FEA and just perform the analysis again. Now you can see that the model is being analysis. It's running the background Nozzle Pro right now, and it's performing the analysis in the Nozzle Pro, and you'll get the results right now on the screen for the FEA results to you. Okay, and this report, what you're going to show is a typical Nozzle Pro output. If you perform the analysis Nozzle Pro separately also, you will get the similar type of output for you, of course. So the analysis is going on right now. The analysis is completed. How you know the analysis is completed? These are the two buttons, which is you can see this results to see for the FEA results. So that there is a text output, there is a graphic output. I'm clicking on the text output right now, and you can option to see here now. This is the output which you got it from Nozzle Pro. The immediate intention for me is to check this one, ASME overstress area. So I'm just going to compare as per the ASME, and I'm just want to find out if there are any overstress areas available. So click on this particular point, and I got the results. No overstress nodes in this model, which means this nozzle with the same load which we have applied, which is the system is pass. So there is no overstress area. Okay, I just want to find out what would be the additional the loads, which is, or what is the load, the maximum percentage which is available. You can option to see this is the highest primary stress ratios. It says about 84 percentage. That's on the plot number 1, which is for the sustained PL, sustained condition is about 84 percentage. You remember that we have seen is about nearly 127 percentage, right? But here is about 84 percentage in this place. If you see again, it is giving the additional informations of the analysis on the same sustained conditions and then expansion conditions too. The reason is WRC 107 does the analysis only for the header. Actually, it does not perform the analysis for the branch, which is nozzle, because WRC 107 will not normally does not address the run area, the branch area. Sorry. So whereas in FE analysis, once you perform, it does the analysis for both vessel as well as for the nozzle, for the run as well as for the branch, both. So that's the reason you are getting some more additional load combinations in this place. Okay. So, okay, let me try to understand here. I'm just getting the 99% in one place, that's on the maximum side, and you can see that is happening on the plot number P1. So I can just go here and I can see what's happening on that P1. So here is my plot. Okay. So the actual stress is about 205 MPa megapascal. 205 megapascal is the actual, but the allowable is 207. So we are very near to the border, of course, but within the limit. So that's the reason the system is saying no overstress area, of course. So and I can now position to see the bit of the graphical results. I can just go back to this screen now. I'm just close down the text window which you got it, and I'm just going back to the graphic window now. So I know that the case one, it has a 99% is the maximum stress. I can just go and click on that. If you see the number of scenarios here, it has a bit of additional scenarios. This PL plus PB plus Q plus F, which is something is not there in WRC because the F is for the fatigue cyclic load, of course. So that also is going to be considered in the FEA's analysis. So that these are the additional load cases has been built with respect to the same. Okay, let me just go to that case number one, and you can option to see the animated view of the nozzles results. One good thing, if you see that typically FEA means people are worried on many things. First thing is the modeling, how to model it in a general purpose FEA analysis tool, then defining the boundary conditioning, then the meshing. I need to have a normal meshing on the vessel area, whereas when it comes to the nozzle and shell junction, the meshing need to be a bit of crude mesh, very smaller, fine meshing is required. Here, the Nozzle Pro is typically as a template driven, so it is going to take care of all these requirements automatically for you. All that we have done, we have in the CodeCalc area, we just gone and changed WRC 107 to FE analysis, and we are getting the results for the same applied load. Okay, and these values what we are just showing is the highest value. It's not the failure point, it's the highest stress point. So the highest stress point, which is about 99 percentage, we are getting at that this particular point, of course. So it's just putting this arrow mark and it is showing you that where exactly the highest stress point is happen, of course. Sometimes people likes to see a bit of fancy thing, so probably you can push and have this one, of course. So that's a maximum stressed point. Sometimes in this case is about 99%, but sometimes it could be even 80% or 70%, but the product is even it's going to be 100 plus, of course. Okay. So typically one thing what we have understand from here is the system which is got failed in WRC 107 because it is not the right tool to doing for the reinforcement pad nozzles or hillside lateral or the D by D ratio as I indicated in these things. So these areas, then obviously the results from WRC 107 is approximate results. It's slightly on the conservative side. It's not going to be the correct one, of course. So whereas when you perform the FE analysis, it is going to calculate the appropriate SAF values and reproduce the results with respect to this and compare with the ASME, and it will give the actual results to you. So that's a place where you are trying to improve your analysis. Sometimes it is definitely going to help to save a thickness of your nozzles or the reinforcement pad. So that's a place it's going to be add value to you. All right, in nutshell, if you want me to say, the last thing is what is the benefit. The first thing is obviously to overcome the WRC limitations, the repad analysis, lateral hillside nozzles, which you can question to perform the analysis by using the Nozzle Pro, and to perform the FEA calculations as per the TEMA 9th editions. Nozzle allowable load for the vessel manufacturer. This is something which is it's a required output. Typically, people will ask you what is the allowable load for the nozzles, because you are a vessel manufacturer and you have to give me the allowable load for the nozzles, and that's one output, of course. Here probably I can just show you. Let me just see whether I can just have that value. Where is my CodeCalc? Okay, yeah. So this is a CodeCalc, and if I go to the text report, and you can see this is a. If you go and click on this allowable loads, So this is my nozzle allowable loads. For these nozzles, what we have been given, so it has given the allowable load information for you. So this is a pretty useful features for the vessel manufacturer, so they can provide the what is the nozzle allowable loads to the customers from here. And work inside PVElite and CodeCalc environmental. You're not trying to learn a new product. You're not trying to learn how to model in FEA, how to do the FEA analysis, the methodologies, everything which is not mandatory to learn all these stuffs. You're just in the same PVElite and CodeCalc environmental. All the input which you have been done has been done. You're just going and shifting the analysis method from either TMO to FEA, or my TMO to FEA again. Both are TMO only, but FEA is the 9th edition of TMO, of course. Similarly, for the nozzles, it's from the WRC 107 to FEA. So that's a pretty straightforward changes which you are doing it, and rest all the analysis performance is going to take care, and you are going to get the output with respect to the same. So by means of adding up the Nozzle Pro into your system, you can position to fulfill all these limitations, or the requirements what you will be having. It can be done, of course, to you. All right, time for question and answer section. Let me just go and click on the questions and see, do I have any questions here to answer? FEA for expansion joint is done by Nozzle Pro or FEA FZCO software developed by team of PRG. Okay, it does by both, of course, because the PRG created a product for Tima. So I believe, I'm not sure about the name. I assume from this message, probably the PRG Tima developed product name might be FSSE. Probably yes. But if you see that the same is being implemented into Nozzle Pro 2 right now for PVElite, so the result size is going to be the same. So, but only difference is that is like a standalone product which you are using it from the TMA side. Here it's going to be implemented within the PVElite. It works in PVElite environment. So that's another good thing for you, of course. Can we use solid element? Yes. The Nozzle Pro has the options to do both the shell as well as the brick. Okay, so when you go to the brick, then obviously you can option to define the thickness, and then for the thickness also it does the meshing. So this facility is also there, but when you want to go such kind of solid element, then you just need to go directly to the Nozzle Pro, and you have to do it, of course. We have few option buttons. In this options button, you can option to control all these things. Probably I can just show you that right now. Let me just go and open the Nozzle Pro from PRG directly, the product. As of right now, we are seeing from PVElite or CodeCalc, but now this is a product which is exactly is going to be like Nozzle Pro. And you see here is the options. So these options will be in a position to helpful to do few things. Okay, like you have the 3D shell element, and then you have the 3D asymmetric and brick element. So when you go for this is going to make you this is going to create the brick element, where you can option to define the thickness, and for the thickness also you can option to have the what you can say, the meshing part and other things, of course. Currently I do not have a sample to show you, of course, but you can do, of course, yes. And these options has a facility to control your meshing options too, of course. Suppose if you want to do even furthermore fine mesh, I need to increase the mesh sizing twice finer, I can option to do it. Similarly, if you want to go for unstructured mesh, typically some of the areas, the unstructured mesh might be useful on the head on the dish end, if you're putting a nozzle laterally, then the unstructured mesh is going to be helpful. You can still do the same, of course. So that facility is also there available in this product. Okay, what if two nozzles close to each other? Can we model that stress interactions on the shell? Okay, see, Nozzle Pro, it is like a component analysis. It's going to take care of only one nozzles, but Pauline Research Group have one more product called FE pipe. So FE pipe is a full-fledged FE analysis for the pressure vessel and then piping. In that place, you have a facility to model the whole vessel, and you can put the multiple nozzles, and you can position to study the interactions between the same. So Nozzle Pro, it's like a okay, if you see in this place on the screen, this is the FE pipe. When you buy FE pipe, then the whole Pro series, which is Nozzle Pro, Axi Pro, Mat Pro, everything is going to come along with the FE pipe. FE pipe is their prime product, which has a facility to model the complete vessels, and you can put the multiple nozzles and you can perform the analysis on the same. Whereas in Nozzle Pro, it's like a one nozzle at a time. So we are doing it individual calculation like WRC. You are applying the load for that WRC load for that particular nozzle, and you are performing the analysis. So that's all. The same way the Nozzle Pro also work. When you want to check the multiple nozzle interactions, then you need to go for the full version, which is a FE pipe. By using that, yes, you can a position to do it. Whether we have option to fix the free bottom and top end of the vessel. If not, then what is considered by CodeCalc? Okay, yes, we can fix this. Of course, there is a facility for you to provide these values. That is, again, this is also available again under the options. I'll show you that right now. I think it's not fully open. Let me just open this again. You can see here the boundary conditioning, free positive cylinder head. I'm just highlighting it now. This is the place, of course. Free positive cylinder or cone or negative. So you have option to do it. So you can define that, of course. You can do it in Nozzle Pro. And what if two nozzles close to each other, that I have addressed. Whether we can option to fix the free bottom, yes, that have been discussed. Solid element, which has been discussed. All right. I think I have addressed most of your queries, and thanks for joining this webinar. And we will be doing such webinars in the futures, of course, to have more information. However, I would be happy to receive your comments and emails on this for any further more queries, and we are happy to come to your office and to show this presentation in detail, to explain all the facilities available in this product, to discuss your requirement and how we can push to fulfill the same. I'm just winding up this section today. Thanks for attending this webinar, and next week we have a webinar on CADWorks, that's on the 3D modeling side. So, and whomsoever is interested, kindly go and register for the same. Thank you.